So thanks everyone for joining. This is the Arm64 Linux Kernel architectural update. I'm Matteo Carlini. I'm a Director of Software Technology Management at Arm. I'm part of the open source software group in Arm, and I look after the Arm64 kernel roadmap, together with other firmware projects as well. So first of all, a news regarding the naming convention of the Arm architectural features. So this comes from our friends and colleagues from the architecture team. So effectively, the A-profile architecture has changed the feature names, and you can find on this page, which I linked there on developer.arm.com, a mapping between the old name and the new name. So you can see that effectively Arm is trying to move away from identifying each feature with a specific revision of the architecture, so 8.0, 8.1, and so on, and just moving to a simpler naming scheme where there is the fit_name. So this should hopefully also clear out some confusion around features which get added in some revisions of the architecture, but then they can be used in previous revisions of the architecture because they are optional. So we just refer to the feature name moving forward, and that should help possibly clarifying all the list of features. As a result, we also updated our specific open source software kernel page. We do have an OSS page for Arm64 Linux kernel architectural features. This page basically tells for each of the feature in which kernel revision the feature has been merged. Some of them are marked still as TBD or ongoing, and there are some notes which explain the development status for those. So we also updated this table with keeping the old naming scheme, the new naming scheme. So hopefully, again, this will help doing the mapping and clarifying also in which kernel we included each one of the architectural features. From 8.1 here down to 8.6 at the moment. So I did a similar slot last Linaro during the tech days in March, and I did present kind of a flowery meadow like this one, which was well received. So I thought of showing it again. This was the picture from last March, and effectively it does represent the enablement status of the features in the kernel, still using kind of the old naming scheme, but at least referring to the revision of the architecture in which those features were added. Then I can update it for next time, maybe. The color scheme is pretty simple. Green is for features that are already merged in the kernel. Yellow, or light orange, whatever it is for features which are ongoing, usually on the list. And red, or light red, is for features which are not currently in the works, are under internal investigation or analysis, TBD, let's say. With light gray are instead features that we believe there is nothing to be done in the kernel, so they are not applicable in the kernel. So this was the picture in March. Now I have an update, a new meadow, which shows the picture today. Now, I'm not going to ask you to spot the differences. The next slides, which follows, tries to explain what changed. But roughly speaking, so you can see that we are mostly all green up to 8.4. In 8.4, the only things which are still ongoing, well, there is the long-standing nested virtualization enablement, which is both an 8.3 extension and an 8.4. MPAM is still ongoing. I have a dedicated couple of slides for that. And then we are completing also the debug and trace enablement for 8.4. And this kind of completes the picture for 8.4. 8.5 is also reasonably green. We've done all the major enablements, with the last one missing so far is memory tagging, which is again progressing quite well towards merge. I have a dedicated slide for it. What's missing? Few actually investigation activities regarding speculation barriers in the context of some specific kernel subsystems, for example, eBPF. So how those barriers can be helpful in those subsystems. And then there is an enablement on the statistical profiling extensions, SPE, which has been introduced in 8.5, but it's one of those features which can be retroactively implemented. So it was listed as an 8.3 SPE feature. Moving on, 8.6, we've done basically half of the enablement. Now, which is the reasoning process here? So we are giving usually precedence to the features which are known to appear in upcoming ARM cores or ARM SoCs. The other features are under investigation. Some of them might appear in the kernel quite soon. Some of them might be a bit late in the process, depending again on timing and priorities of the hardware availability also for testing these features as well. The last flower here is around future architecture technologies. This is today pretty much unchanged. We enabled SV2 in user space. There are patches to enable the transactional memory extension, TME, on the list, but given that we haven't heard any specific pull from the market or the ecosystem around this feature, these are, at the moment, they are hanging there in the list, waiting for some more concrete use cases for that. So this is the picture of the enablement today, but I also have a news, kind of a forecast from tomorrow. And when I say tomorrow, I literally mean tomorrow, Wednesday, because I invite you actually to participate to this session in which my colleague Martin from the architecture team will present the 2020 architectural extensions from ARM, which again, they are labeled 8.7. I'm not going to enter into the details right now. From a kernel enablement point of view, we are just effectively investigating the new spec, the new extensions, and putting the enablement features in the backlog with the same kind of priority that I said before. So features which will come in upcoming ARM SoCs or ARM cores will be prioritized first. The 2020 extensions also comes with a couple of features which does not fall into the 8.7 nomenclature. Martin will explain everything tomorrow, but effectively they are marked as future architectures. So one is CSRE, call stack recorder extension, and the other one is BRBE, branch record buffer extension. Again, please do join Martin's session tomorrow for knowing more about those. Now, quick snapshot of what happened since March 2020, last Linux Tech Days. Back in March, I did present the updates for 5.6 kernel, so a couple of 8.5 feature, again, using the old nomenclature. I'm gonna update next one, I promise. The random number generator and E0PD has been enabled in 5.6, and a bunch of the 8.6 features as well has been exposed to user space. Then here it comes 5.7. So 5.7 comes with the complete enablement of pointer authentication, so the feature introduced in 8.3. In 5.7, we enabled the in-kernel support for functional return address protection. All the user space exposure was done already in previous kernel revision, 5.5 and before. I explained it all in the March discussion. Few other features exposed here, activity monitors extensions included, PMU counters extended to 64-bit, the use at boot of the random number generator, some preparatory work for the 8.5 branch target identifier extension, BTI. So in 5.7, we managed to merge some assembler refactoring, assembler annotations refactoring in preparation for BTI. And then from the community, from the KVM ARM community, there was support for the GIG 4.1 system IP, and the maintainers also decided to remove the 32-bit host support, with 32-bit guests still supported on a 64-bit KVM host machine. 5.7 comes as well with memory hot remove support for Arm64, which also concludes a long-standing enablement that we did for memory hot plug and hot remove that was outstanding. moving on, we've got 5.8. So finally in 5.8, we managed to merge BTI. So BTI is the architectural extension which protects against jump-oriented programming attacks. And usually it's thought to be deployed together with pointer authentication because they protect with similar attack. In 5.8, we merged both the user space and the in-kernel support for BTI. And that was kind of an achievement because it was outstanding for a while. Plus, the KVM ARM team is working also on some pre-nested virtualization patches, which mostly comes from the community and from the maintainers. This is all in preparation to the full support for nested virtualization, which is quite heavyweight. 5.9, not yet tagged. I guess we are at RC6, about to enter into RC7 for 5.9. But we have a few things which are already merged and going in the right direction. So we finalized, again, thanks to the community, 2 features from 8.4, TTL and TLBI. This has been queued and merged in 5.9. In terms of specification support, we managed to develop and merge the SCMI notification support. So this is for the SCMI power management spec, which our colleagues will have different talks about that during the week. And then again, some further KVM enhancement and preparatory work for nested virt. Now a bit of prediction for 5.10. Well, these are all things which are already queued in next, so fingers crossed they will appear in 5.10. Pointer authentication. So what was missing in pointer authentication? Well, there was an extension that was added in the 8.6 revision of the ARM architecture, but these extensions were called 8.3 pointer authentication 2 and 8.3 fault on pointer authentication instructions. And those required an enhancement in the kernel, so support for the fault handler and some changes for the PO algorithm. And these have been, again, developed, queued, and will appear in 5.10. As a teaser for MPAM, we'll also manage to upstream, finally, some of the preparatory rework and cleanup patches of the resource control interface that we are working on for enabling MPAM. Speaking about MPAM, let's talk about that. So you might know or you might remember that for MPAM, we are enabling the ARM support based on an interface which is already there. It's an Intel interface, x86, which is called Intel from an Intel RDT technology. And the interface is called resource control. It's already there, it's used already in deployments. So we couldn't do differently rather than enabling the Arm64 backends against that existing interface. There are a lot of patches for reworking this interface and making it multi-architecture because it was not originally. All these patches are available and developed for examination in this developer branch, which we are constantly rebasing and updating. As I said, the first bunch of patches are in next, queued on top of 5.9, so they will hopefully make 5.10. Now here down below, I summarized, again, as I did in March, what does the REST control interface allow to do versus what the ARM architecture and PAM controls would theoretically allow to configure. And mainly, so the resource control interface allows to configure cache portion bitmaps for layer 2 and layer 3 cache up to 32-bit portions, and similarly for memory bandwidth portions as well on layer 3 cache. We have some initial thoughts on how to enable other extensions of the ARM architecture and PAM, but that will come after we manage to successfully upstream all the pieces for plugging the MPAM Arm64 specific driver with REST control. And so if we are talking about a bit of planning or looking ahead for MPAM, So first of all, what is the system description? So there is a spec which is available in beta. It's available for our partners to download. It's not yet widely available to the community, but it's we are hoping to finalize it in October, so in a month from now, actually. And that is for ACPI. The device tree bindings will be effectively worked upon and derived from the ACPI bindings as well, once we manage to finalize those. The development plan, so we are expecting, we are mid of September now, end of September, we are expecting to continue the rework of the resource control interface throughout all the rest of 2020. So really making the interface multi-architecture. There are tens and tens of patches to do that are about to be posted on the mailing list in the next cycles, actually in the upcoming 5.10 iteration. The Arm64 specific backend, the architectural enablement, is expected to land on the list starting from 21, once we manage to upstream the resource control reworks. There are a few bits and pieces that we are comfortable in upstreaming anyway in parallel. So things like the system register descriptions and CPU feature enablement will likely be posted during the 5.10 iteration anyway, so you will see them appearing. Now, a recent development that I would like to mention is also that we are looking into which are the mobile-driven use cases for MPAM in an Android scenario. So how we would like to enable MPAM in an Android system, and how does that match with the concepts of JKI from Google. So these topics are currently under investigation, and together with that, we are also investigating the possibility of having another in-kernel user for MPAM that would be effectively an alternative to resource control, and can also provide an alternative path for upstreaming the Arch Arm64 code. Because if we can prove that there is another user, then effectively we wouldn't have to necessarily wait for the resource control interface to be stabilized. That's the situation on MPAM. Now moving forward, just time check. Few other things, sparse things which are ongoing in terms of architectural enablement and spec enablement from the Arm64 team. So from the good old A.2 spec, the statistical profiling extensions are not yet exposed in KVM guests. That was a known gap that we are trying to cover right now. So we are working to enable that and will be soon posted on the list. I mentioned memory tagging. So memory tagging is progressing quite well, actually, towards merge. At the moment, we are only enabling scenarios with heap tagging, and that is what is under development for both user space exposure for Android systems, for example, or other commercial distros to pick up, and also what has been ongoing in the kernel. And in-kernel support is now co-developed with Google. There are common patches available on list between Arm and Google that tries to enable the in-kernel heap tagging support. The user space enablement, again, prediction here, take it as a crystal ball, are likely to be queued for 5.11, but as usual, no promise. We are hoping that the patches are in a good state for going in by then. We also did enable KVM guests in parallel. Why that? Well, to spot if there were any issues in enabling it in guests. The enablement is on the list, again, for heap tagging, and it's available for testing or comments. As I said last time in March 2, the stack tagging support is currently, let's say, paused. So we did an early investigation, and we know that the fine-grained stack tagging, so tagging for each function, for each stack function, which will break a single image of the kernel, and we don't want that, even though there might be some deployment scenarios which can get away with that. But from a general kernel point of view, this is not really acceptable by the maintainers. So we are kind of having the backlog an activity to think about how stack tagging could be enabled and deployed, possibly as a debug feature. Then again, that will depend on GCC, mainly GCC compiler support, which will have to be worked on as well. So that's the story for memory tagging. Now, last bullet point of the slide, debug activities and core site. I mentioned we are working to complete the 8.4 enablement for debug and trace. There is an ETM, embedded trace module 4.4 currently on list. And thanks to the community, there is also support for self-hosted trace on list as well. And even the possibility to build core site as a module, which is kind of an interesting thing. Internally, it's not yet on the list, but internally, we're also working to enable some new extensions of the debug and trace, which have been announced last year as part of the future extensions of the ARM architecture. And these are called the ETE, Embedded Trace Extension, and TRB. We'll soon see the light of the list, possibly during the 5.10 iteration. I have one last slide, again, snapshot of other ongoing developments. So you might know ARM is proposing also a firmware framework for A-class, which is called FFA. There is a spec, public spec available at this link, and this provides effectively a defined interface for allowing VM communications or normal word to secure word invocation of services. These can be either used by hypervisor in the normal world for allowing VM to VM communication, but also, as I said, for invoking some secure services deployed through a trusted OS in the secure world. So we are working publicly on the list to support both the scenarios, so both the users of this interface, and we are hoping to progress the driver pretty soon as well, before the end of the year. Another different spec, which has been recently published as an EAC, early availability by ARM, is the True Random Number Generator, TRNG spec. It's available at this link. It introduces support for a new SMC for standardizing the communication between kernel and firmware. So this will also imply changes in the EL3 firmware to accommodate the new SMC. And few changes also to handle the entropy source. This is currently under internal enablement, and again, we'll see the light soon. It's kind of another teaser of what's going on. In terms of SCMI, as I said, we completed most of the enablement already in the kernel. What is out at the moment is a system power protocol support, which has been already queued actually next. But that needs a separate control driver, which has been kind of discussed during the review of the protocol. And this driver is currently in development on list. So it will appear in one of the future iterations as well. A couple of other random enablements. So one is the system IP. There is a new interconnect, CMN600, that requires a PMU driver for handling PMUs. This is currently on the list under active review, tested by partners and community. And last thing I would like to mention around Morello. So Morello is a research project actually sponsored by ARM. I'm not going to spend too many words here. From a kernel point of view, there is an investigation activity for basically understanding how the capability-based ABI could be enabled in the kernel. And this is going to be a very intrusive enablement. It's a joint collaboration between various teams in ARM and Linaro, toolchain teams, user space, Android teams, and so on. There is a brilliant Linux Plumbers presentation, which I pointed here, which describes the capability-based ABI developed as part of the Morello project. So I encourage you to go and look at that if you're interested.